Good morning, sir. I, Anand Goel, and on the behalf of Group 12, I am pleased to present our hostel management system project. Our team consists of myself, Anand Goel, Suraj Meena, Bernal Shah, and Riya Saharan. Today, we will walk you through our complete implementation from requirements to live demonstration. The current hostel management process relies heavily on the manual paperwork, leading to inefficiencies in student allocation, room maintenance tracking, and the staff coordination. Our system aims to digitize these operations entirely. Let me explain our software requirement specification. Business objective. First, provide real-time dashboards for administrators. Second, eliminate manual paperwork through digitized workflows. Third, secure sensitive data using JWT-based authentication. And fourth, enforce consistency in room allocation and capacity management. What's in scope? User authentication. With role-based access control, complete student lifecycle management registration, room allocation, and availability tracking. Room maintenance workflow for cleaning and repairing tasks. Staff management with duty scheduling, admin dashboards with analytics. Now, what's out of scope for version 1.0? Payment based integration planned for future releases, IoT based access control systems, native mobile applications. Our functional requirements. It cover main five areas. Account management. JWT based login with admin bootstrap using admin at the rate gmail.com. Student management. CRUD operations with batch filtering from 2016 to 2020. Room operations block wise room listening for block A through D with maintenance task registration and staff coordination, staff records with availability toggles. Dashboards, occupancy, visualization, and overdue maintenance alerts. For non-functional requirements, we have ensured API response times under 500 milliseconds, bcrypt password hashing with 10 salt round for security, 99% uptime target, WCAG accessibility compliance. Now I will hand over to Suraj Meena, who will explain our system design and UML
Thank you,
diagrams.
Anand. Good morning, sir. I am Suraj Meena and I'll walk you through our system design using UML diagrams. First, let's look at our architecture. We have used the OneStack front end, React 16 with Redux for state management and React Strap for UI components. Backend, Express.js with Passport JWT for authentication, database MongoDB with Mongoose ODM, security JWT tokens with HS256 algorithm, and bcrypt hashing. This is our three-tier architecture. At the top, we have the React SPA communicating with the Express REST API over HTTPs. The API layer handles authentication, validation, routing. Below that, we have three service modules: student service, room service, and staff service, each managing business logic. At the bottom is our MongoDB database storing all collections. The key feature here is the decoupled design. Front end and back end can be scaled independently. Now our use case shows three actors: admin, student, and staff. All three can log in, but only admins can manage students, rooms, and staff. Notice the extend relationships. For example, manage student extends to added student. This shows our role-based access control in action. The class diagram illustrates our object-oriented design. We have a base user class with common attributes like ID, name, and email. Student and admin inherit from user through generalization. Relationships. Students occupy rooms that one-to-many association, meaning one student can occupy zero or more rooms over time. Admins manage rooms, showing the administrative control. This sequence diagram is crucial. It shows two workflows. First, authentication flow. User submits login credentials. React dispatches the login user action. Redux posts to API users login. Express validates the payload using Passport JWT. Mongoose queries the user selection in MongoDB. Bcrypt compares the hash password. If successful, a JWT token with 2-hour expiry is returned. React stores it in local storage and redirects to dashboard. Second, student creation flow. Admin submits student form. React dispatches add student action with JWT token. Express verifies the token using passport. The ensure admin middleware checks if user has admin privileges. Validation occurs before database insert. MongoDB creates the student document. Redux updates the student list and UI refreshes. The component diagram shows our modular architecture. Web interface connects to authentication, which gates access to student management, room management, and staff management. All three feed into reporting, and everything connects to the database layer. Finally, the state diagram for room status. As room starts in available state when allocated, it moves to occupied. If any issues is reported, it goes to maintenance. After completion, it returns to available. Rooms can also be decommissioned from either available or maintenance states. These diagrams collectively show a well-structured, secure, and scalable system design. Now let me hand over to Mrinal, who will demonstrate our testing strategy and results.
Good morning, everyone. My name is Mrinal, and today I'll be walking you through the testing strategy and the performance results of our hostel management system. So to ensure that our application is reliable, secure, and free from major failures, we've implemented automated backend testing using Jest and Supertest. So these tools allow us to validate real API responses under controlled conditions. So we've used around 7 test cases, out of which around 5 have passed and 2 have failed, which gives us an overall success rate of 71.43%. So this result confirms that the core system is stable with only minor refinements required. So all our testing was conducted in a controlled and isolated environment to avoid affecting the production data. So we've used Jest as our testing framework. We've used Supertest for HTTP request validation. We've used Node.js runtime and a dedicated MongoDB test database. So this setup ensures that the test results are accurate, repeatable, and reliable. And so now let me briefly walk you through our authentication test cases. And I'm happy to report that all of them have passed successfully. So the first test case, if we've seen for our authentication part, is this one right here. This is for login with valid credentials. So this is the API endpoint should be API users login. And we were expecting 200 OK with a JWT token. And this one has been passed. And the second one here is a login with a non-existent user. So we were expecting a 404 error. That means not found. And this also was passed. The third one being registering with an existing email. So we wanted a 400 error with a bad request, and this also passed. So these results confirm that authentication system is secure and behaves exactly as expected under different scenarios. And the fourth test case over here, and the fifth one at that, we've tested the student management module, which is one of the most critical parts of our system. So the fourth one over here is fetching all the student records. So we were expecting a 200 OK with student data, and this one also was passed. And the fifth one, this particular one, is creation of a student with invalid token. So we expected a 401 unauthorized access, which also passed. So these passing tests verify that our authentication, our authorization system successfully blocks the unauthorized access. And we have 2 failed test cases, these 2 ones. The first one being the creation of a student with missing required fields. So we expected a 400 bad request, and we expected the actual that we found was a 401, a 400 error, which was for unauthorized access. And the last one over here, which also failed, is for the creation of a student with invalid email format. And here also we expected a 400 bad request, but we got a 401 unauthorized. So we looked at the root cause, and the authentication middleware is expected before input validation, which causes the validation errors to be hidden behind authorization headers. So this is not a security weakness. We need to understand that. In fact, the authentication should come first, but our error handling messaging, it needs refinement, which is something that we've already identified for improvement. So now I'll just quickly demonstrate the testing results. So if I just say npm test here. So as you can see on the screen over here, we have 2 failed and 5 passed. And here we got a 401 instead of a 400 as earlier discussed. So this proves that a test suite accurately detects the expected behavior as well as the real flaws. So to summarize the issue, technically we can say that the current flow is somewhat like this. We have the request going to the JWT verification, then we have the admin check, we have a validation, then it's going to our database finally. So now this is correct for security, but the error response structure, it needs to be improved. So validation problems are reported clearly after the authentication. So based on our testing results, we propose the following improvements. The first one being an implementation of a 2-level validation. So we can have a basic check before the authorization, and then we can have a deep validation after the authentication. We can also use an express validator for structured input validation. We can add any custom error messages for different kind of failure types. We can also expand testing to include batch boundary testing. And also we can do a multi-step student room allocation flows. So we can have a separate workflow for each of the allocation types. And this can actually kind of help us increase the overall test coverage beyond 90%. And these upgrades will make our system even more robust and production ready. So even with 2 minor failures, I would say that our system has proven to be functionally stable, secure, and thoroughly tested. So these issues, they're not flaws in logic, but yes, there are opportunities for refinement, which is exactly what professional testing is all about. And yes, so we do hope to uncover those. And with our system now fully tested and validated, it's now time to see everything in real action. So I now invite Ria Saran, who will demonstrate the live working of our hostel management system. So over to you, Ria.
Thank you, Mrinal. Hi everyone, I'm Riya Saran and I'm excited to show you our working application. So this is our landing page, clean professional interface showcasing the project overview. Now I will log in as an administrator using our Bootstrap credentials that are now here's the admin dashboard with navigation tiles for our core modules. See the clean cards for student, rooms and staff. The dashboard shows real-time statistics. For total students, the respective dashboards with these cards shows real-time statistics, total students, available rooms, active staff members, etc. So let's say if I click on manage students and for best 2023 I want to add any of the student. Let's say the name of student is John Doy, email address is john.doy1@example.com, and the student ID is, let's say, 2023 UCP 1704. Gender is male. Block is, let's say, B, and room number is 102. If I add this, watch as the API validates, insert into MongoDB and update Redux store in real time. There it is, student added successfully. The list auto refreshes. We can see that the students are already filtered by their batches. And if I want to delete any of the students, I can do that by clicking on this delete icon. You can see here the student has been deleted from the list. Now if I navigate, and also we have a feature that we can search a student by student ID, room number or status. Let's say room number, it's 101. Okay, we can see for 101 John Doe is there. Now if I navigate to manage rooms, here all maintenance tasks for block A can be seen, and I can quickly add a maintenance task over here also. For room number 102, cleaning is added, date and time are this, and staff name would be, let's say, John Doe only, occupancy is boy, and we can see here a new task has been added successfully. Finally, if we go to the staff module, we can see the if I try to add any of the staff members, let's say this is the staff member I'm going to add 898. I can toggle this button and change the availability or non-availability of the staff member. So this is all about the admin login. If I log out and log in again as a student, not as admin, I will not be allowed or I will not be authorized to do many of the tasks. Like if I click on manage students, I would not be able to delete this student named Ria Aran. I will not be able to do this. Okay, we can say it here. And can also show you our database. It has 4 modules: room, staffs, students, and users. So this database syncs in real time with our activities in the website. And all passwords hashed with bcrypt using 10 salt rounds. JWT token expire after 2 hours to prevent replay attacks. Admin only routes protected by ensure admin and middleware. Input validation on both server and client sides. HTTPS assumed for production deployments. Now, Our project statistics are, we have used 15 plus API endpoints, we have 4 collections and 20 plus front-end components. Test coverage is 71.43. And in conclusion, our hostel management system successfully digitalizes hostel operations end-to-end, implements secure authentication and authorization, provide intuition admin interfaces, ensure data integrity with validation, offers scalability for future growth. The system is production ready with documented areas for enhancement. We have built a solid foundation that can be extended based on evolving hostel management needs. Thank you.